differentiate. So example 1, the implicit differentiation, x y squared is equals to sine y cubed. So you cannot use direct differentiation simply because you cannot make y the subject of this equation. So directly this qualify to be an implicit equation. So, and for you to differentiate this, you start by differentiating on both sides. So differentiating on both sides, differentiate on both sides, you have derivative of xy squared is equals to derivative of dx sine y cubed. From this, you have x y squared sine y cubed. So in this part, you use product rule. So you differentiate this, you hold that. You hold this, you differentiate y squared. It will be d dx dt, derivative of x, you hold y squared, plus you hold x, derivative y squared is equals to, in this part, we use chain rule. So chain rule, you find derivative of this in general. So it will be cos y cubed, derivative multiplied by derivative of y cubed. Yes? Are we together? Yeah. So derivative of x is 1, y squared plus x 2x y, derivative of y squared is 2y. But you have y, you put dy over dx is equals to derivative of y cubed is 2y is equals to 3y squared cos y cubed dy dx. So in this, it is simpler to make dy dx the subject. So y squared is equals to 3y squared cos y cubed minus 2xy dy dx. So your dy dx will be dy dx is equals to y squared divided by 3y squared cos y cubed minus 2xy. So this is the required solution for this equation. Dy dx y squared divided by that. You can simplify it further by factoring y. Like that, like that, like that. Example 2, find derivative of x squared y minus y cubed is equals to x minus 7. This is an implicit equation. So we differentiate, we take derivative on both sides, like derivative of x squared y minus derivative of y cubed on both sides, so x minus 7. So you have two functions, x squared and y. Normally, I will use product rule to differentiate. I differentiate x squared, I hold y. I differentiate y, I hold x squared, like that. So derivative of x squared, I hold y, plus x squared, I differentiate y, minus derivative of y cubed is equals to derivative of x minus 7. So derivative of x squared is 2x multiplied by y plus x squared, derivative of y is 1. So dy over dx minus 3y squared dy over dx is equals to 1. I isolate dy dx on left side like x squared minus 3y squared dy dx is equals to 1 minus 2xy is equals to 1 minus 2xy. This implies that dy over dx is equals to 1 minus 2xy divided by x squared minus 3y squared. Your required solution. Example 3. Y raised to the power 6 minus e raised to the power xy is equals to x. We use the same criteria of finding derivative on both sides. So you find derivative on both sides. Because this is an implicit equation, the derivative of that y raised to the power 6 minus derivative of exponential xy is equals to derivative of x. So derivative of y raised to the power 6 is 6 y raised to the power 5 dy dx minus derivative of this. Remember, if you have something, find the derivative of exponential x. How do you go about it? You remain with this, then you find derivative of x. You see? So the derivative of this with respect to y will be simply because the derivative of x is 1. So the same criteria follows under this. So derivative of e raised to the power x y will be e xy. Then you find the derivative of xy is equals to derivative of x. Are we together? So 6y raised to the power 5 dy dx minus. So under this, we simply use product rule. So you have y plus x dy dx is equals to 1 plus x dy dx is equals to 1. You isolate dy dx on the left side. You have 6y raised to the power 5. You have dy dx. You open this minus exponential xy x. You see that x dy dx is equals to 1 plus exponential xy multiplied by y. So on the other side will be plus y x raised to the power xy. So your dy over dx will be 1 plus y exy divide 6 raised to the power 5. 6y raised to the power 5 minus x exy. It is simpler. It is simpler.